Good day, everyone. You are welcome back to Idowu Maths class. We are still dealing with statistics. Today, we are considering measure of dispersion. What is measure of dispersion? Measure of dispersion includes range, mean deviation, variance, and standard deviation. Let's take them one after the other. What is range? Range of a distribution refers to the difference between the highest and the lowest value of the distribution. Let's take example 1 on range. The table is given. Find the range and the median respectively from the table above. You can see we are dealing with range, but the question matches both the range and median together. So we have no choice because we want to learn range. We have to deal with the question together. Meanwhile, we have done median before now, so it is not a problem. So what is range? As I have said, range is the highest value in the distribution. The highest score here is 10 minus the lowest in the distribution. That is the lowest, 3. Answer is 7. 7 is the range. Now, what is median? Median equals, to determine that, find the total frequency. 1 plus 6 plus 2 plus 1 plus 2 plus 3 plus 1 plus 4, that's 20. Total frequency is 20. Half of it is 10. Meaning that median will be at 10th plus 11th position divided by 2. And that is, at 10th position, what is it? 1 plus 6, that's 7, plus 2, that's 9, plus 1, 10. This is 10th position. The value that corresponds to the 10th position is 6. Plus, now 11th position. Start again. 1 plus 6, that's 7, plus 2, 9, plus 1, that's 10, plus 2, 12. It is at this place we reach 11th position, even it exceeds it a bit there. That is where we reach 11th position. Look up there, you see 7 as the target divided by 2. So 6 plus 7, that's 13, divided by 2, that's 6.5. But there is an instruction here. Range and median respectively. That is, range first, followed by median. So, we say range, comma, median is, what's range? 7. Median, 6.5. And that tallies with option 7, 6.5. Option D. Look at option A. Is there as a trap for you. May you not step into it. Here, median first, then range. Against the instruction that range and median respectively. So don't fall victim. A is not correct. D is the correct order and is the correct answer. Example 2. Calculate the range of 20, negative 6, positive 25, positive 30, 21, 28, 32, 34, 5, 3, 2, and 1. We have to find the range of this. Range is the highest value. The highest value here is 34 minus the lowest value. The lowest value here is negative 6. Look at it. Negative 6. Not 1, but negative 6. Therefore, 34 plus 6 results. Negative times negative is positive. So, answer is 40. And that corresponds to option D. Let's consider example 3. Find the range of the following set of numbers. 0.4, negative 0.4, positive 0.3, 0.47, negative 0.53, then positive 0.2, and negative 0.2. Well, range here should be, the highest value here is 0.47 minus the lowest value. The lowest value should be, yes, negative 0.53. You will be asking why. The higher a negative value seems to be, the lower it is. You see negative 100, it seems big compared to 2, 3, 4. You would think negative 100 is big. It's not big. As bigger as it seems to be, the lower it is. Negative 0.53 is the lowest in this set of numbers. So let's operate it. 0.47 then plus 0.53, because negative times negative gives positive. So adding these together, you get 1.0. And that tallies with option B. Let's consider example 4. This example 4 is on mean deviation. Therefore, I will take time to explain what mean deviation is all about with its formula, not just solving it. And after it, any other mean deviation question will just be solved straight away. Now, to find mean deviation in a distribution, if it is a non-tabulated data like this, mean deviation, let me use MD to represent it. Mean deviation is summation x minus x bar over n. We use this n to represent the number of elements there, while we use this slash to mean absolute value. In most cases, mean deviation is gotten at absolute value. If we don't get it at absolute value, I will show you in the course of what will happen. That is why we have to get it at absolute value. Mean deviation only is gotten at absolute value. You will understand that when I begin to work. So this is the formula if it is for a non-tabulated data like this, data that is not on table. But for a tabulated data, which will definitely include frequency, it will be summation f into x minus x bar over summation f. Take note of the way I write it. Don't write it as summation f into x minus x bar over summation f. A student told me some time ago that why not use this to cancel this, just because of the way he wrote it. Therefore, write it this way. It is summation of frequency times the deviation. This x minus x bar is the same thing as d, which could represent deviation. Therefore, this same formula could be written as summation d over n, where d is the deviation, x minus x bar. Don't forget, x bar is the calculated mean. Meanwhile, the difference between the x value and the calculated mean x bar is the deviation we talk about. So also here, if you are writing it like this, it will now be summation fd over summation f. I bracket fd to let you know that it is not summation f at the numerator. It is summation fd, not summation f times d divided by summation f. So that is it. This is for tabulated data. This is for non-tabulated data. Let's work this and see out it goes. So 1, 2, 3, 4. They are my x value. You now take time to find the mean of the 4 of them. See the way I want to find the mean. I come here to find the mean. The calculated mean is x bar. Calculated mean, so to say, is 1 plus 2 plus 3 plus 4 divided by 1, 2, 3, 4 divided by 4. So calculated mean will be 10 divided by 4. Answer is 2.5. Look at it very well. If the calculated mean is this, so our deviation will be x minus x bar. Absolutely calculated, meaning that since 1, 2, 3, 4 are the x values, so we take them one by one. You find the difference between the x value and the calculated mean. Calculated mean is the x bar, don't forget. Now, let's take them one by one. 1 minus 2.5. You know, originally it should give you negative 1.5. I want to show you something. I'm not going to write the negative because of the slash, which means absoluteness. When you are getting the absolute value of something, you don't put negative there. You put the difference there without including negativity. So, but I want to show you something. The reason we use absoluteness in mean deviation, I want to show you. Now, let's go. 2 minus 2.5. You know, originally it should be negative 0.5. 3 minus 2.5. It should be 0.5. 4 minus 2.5. It should be 1.5. And since it is the mean deviation we are to calculate, see what would have happened if we don't calculate them at absolute value. See what will happen. Let's add up. Negative 1.5 plus negative 0.5 gives us negative 2. Now, 0.5 plus 1.5 gives us positive 2. Negative 2 plus positive 2 gives us 0. Therefore, your answer will be 0. You'll be stopped there because everything will negate each other and you are stranded. That's why we must not calculate mean deviation like that. We must calculate it at absolute value. Therefore, I'm removing the negativity. Removing the negativity means these are absolute value without considering negativity. Just the difference between them. The difference between 1 and 2.5 is 1.5. The difference between 2 and 2.5 is 0.5. Difference between 3 and 2.5 is 0.5. Also, the difference between 4 and 2.5 is 1.5. So, adding them together, we get 4. Do you understand? Therefore, mean deviation equals, what's our formula? Summation x minus x bar divided by n, which is, what is summation x minus x bar? This is x minus x bar, absolutely gotten. The summation is 4. We put 4. N is the number of occurrence, number of items we have here. 1, 2, 3, 4. It is 4. So 4 divided by 4 is 1.0. If you write it as 1, there is no crime there. But look at the options. Options are written in 1 decimal place. That's why I put my own 2 as 1.0, which tallies with option A in the option.